All right, 4.2 is mostly going to be review, and it deals with square roots. So if I had the square root of 6 times the square root of, let's say, 15, you just multiply what's on the inside, and you get the square root of 90. And then we factor 90. Well, what goes into 90? 6 and 15. 2 and 3. 3 and 5. Does anything come out? Set of 3's. So we get 3 root 10. Easy enough, right? Okay. What if it's 4 root 12 times 3 root 18? Well, you can multiply square roots together as long as they have the same root. And both of those are square roots. So if you had a square root and a cubed root, you cannot mix those. And then you multiply outside and outside, which would give you 12. And then inside and inside. I don't know what 12 times 18 is, but I don't really care. Why do I not care? I'm just going to factor it. Whatever it is will be 12 times 18. 2 times 2 times 3. 2 times 3 times 3. Can I pull anything out? Set of 2's and a set of 3's, which is 6. So the 6 comes to the outside and multiplies by 12. 72 times the square root of 6. What if there was an x in there? Then this would be x squared, and we would bring an x out. What if one of them was an x squared? Then that would be x to the third, and I can still bring an x out, but one of the x's will remain on the inside. Okay? All right. What if we had 2 root 3 times 4 root 6 minus 5 root 10? We're just going to distribute. Outside times outside is 8. Inside times inside is 18. Minus outside times outside is 10. Inside times inside is 30. And then we check to see if they simplify. 30 is 2 times 3 times 5 with no pairs. 18 is 2 times 3 times 3. So we bring out a set of 3's. That becomes 24 root 2 minus 10 root 30. Does that make sense? Okay. What about the square root of 45 divided by the square root of 15? Yeah, we can just call this one big square root of 45 over 15. And 45 over 15 is 3, so it's just the square root of 3. So if you have a square root divided by a square root, just combine it into a single square root and then simplify the fraction. Okay? Yeah. So in the end, let's say I have the square root of 48 over the square root of 2. So that's going to be the square root of 24. And 24 is 2 times 2 times 2 times 3. So bring out a 2 root 6. Yes, you are correct. Okay, one thing you learned last year, if we have the square root of a number in the denominator, we have to do what is called rationalize the denominator. Just like there are an infinite number of ways to write a fraction, 1/2, 2/4, 3/6, there are an infinite number of ways to write square roots. So just to make sure that everybody gets the same answer and to make sure the answer is as easy to work with as possible, one of the rules with square roots is never leave a root in the denominator. So what we do is multiply this by itself, but that would change the problem. What is the only number I can multiply by and not change the result, the original value? 1. So I need to turn this number into the number 1 so that it doesn't affect the scale of my original fraction. So I just multiply by root 6 over root 6. The top gives me 4 root 6. And what is any square root times itself? Just the stuff on the inside. So it'd be divided by 6. Now, those all share a 2. Can I pull a 2 out of everything? No, I cannot pull a 2 out of the square root. But I can simplify this to be 2 root 6 over 3. Okay? If I had the square root of 7 over, well, no, that's not what I wanted. The square root of 7 halves. To simplify this, I create root 7 over root 2. Then I times by root 2 over root 2. And the top becomes root 14. And the bottom becomes 2. Okay? Right? What about the third root of 9 over 4? So we would get third root of 9 over the third root of 4. How do I rationalize the denominator? Times it by itself, but that's not going to be enough. Because that gives me the third root of 16. Is 16 a perfect cube? No, it's not. It's 2 times 2 times 2 times 2, which is 2 third root of 2. So how many of these do I need? I need this many every time. So I need to put a third one there. And now the third root of 4 times the third root of 4 times the third root of 4 is 4. And on top, I get third root of 4 and third root of 4. Now I factor everything. 3 times 3 times 2 times 2 times 2 times 2. Do I have a set of 3? This. So that becomes 2 times the third root of the leftover. 3 times 3 is 9 times 2 is 18. And then I can pull a 2 out of those. And I get the third root of 18 over 2. Okay? What about if I had x to the third times x to the fifth? What would that equal? X to the 8th. What about x to the third over x to the 5th? So we could say x to the negative 2 or 1 over x squared. Those mean exactly the same thing. If you subtract the bottom one from the top, you're going to get negative 2. But if you subtract the top one from the bottom, you're going to get 1 over x squared. And we always prefer positive exponents in our final answers. Okay. Well, what if I had x to the 1/3 times x to the 2/7? How would I solve that? You'd add them. Add the two exponents. So 1 over 3 plus 2 over 7. The common denominator is 21. So 7 plus 6 would be 13 over 21. So x to the 13 over 21. Similarly, if I had x to the 1/5 divided by x to the 4/7. Am I going to subtract top to bottom or bottom to top? Which one's bigger? Which of the exponents is bigger? The bottom is bigger, so we want our answer to land on the bottom. So we're going to do 4/7 minus 1/5. That's going to be 20 over 35 minus 7 over 35, which is 13 over 35. So 1 over x raised to the 13 over 35. And Alex is going to want you to put positive exponents in for your answer. So you'll have to leave it like that. All right, let's look and see what I've not covered so far. Got that one, that one. Got that one, that one. Oh, we haven't done one of these. I cannot add those two square roots together in their current form because they're not the same. It's kind of like saying, what is 4x plus 1y? The x and the y don't match, so I can't put them together, but I can simplify. So 48 is 2 times 2 times 2 times 2 times 3. Wait, 2, 4, 8, 16 times 3. Okay. And then 27 is 3 times 3 times 3. So I pull out two sets of 2's, and I hit those with a 4. So I get 16 root 3 plus 3 root 3. And now this is equivalent to asking what is 16x plus 3x. Since the roots match, if I have 16 copies of root 3 and I add 3 copies of root 3, I end up with 19 copies of root 3. So you are allowed to add and subtract roots as long as the roots match and the number inside the root also matches. Okay, we've done that. Done that. Same idea here. When I put it together, I'm going to get 18x to the 8th. But if you just want to factor it in this form, I have a set of 3's. Oh, and then I have 4 sets of x's with a 2 left over and no x's left over. So 3x to the 4th times the square root of 2. Okay, we've done that one. Done that one. Done that one. Right. So here we're going to distribute. That gives me 7 times the square root of 9. And then this is going to give me 4 times the square root of 18. That one will give me 14 times the square root of 18. And that one is going to give me 8 times the square root of 36. Well, this is just 7 times 3, which is 21. And 18 is 3 times 3 times 2. So that becomes 12 root 2. And this one becomes 14 times 3, 14, 28, 42. 42 root 2. And then we add those together, and we get 54 root 2, and that just becomes 8 times 6, which is 48. 48 and 21 become 69 plus 54 root 2. So you're just kind of using all of your simplifying skills to get that answer. All right, lastly, we have this. Here is a fraction with a square root in the denominator, but the square root is not by itself this time. There are actually two terms in there, 7 and negative 2 root 5. So the only way to simplify this is to multiply the bottom by its conjugate. Do you guys remember what conjugates are? If we have x squared minus 16, that factors into x minus 4 and x plus 4. This is referred to as a difference of perfect squares, and this is referred to as a set of conjugates. And conjugates are important because when you multiply, you're going to get x squared minus 4x plus 4x minus 16. Every single time you multiply by conjugates, those will knock each other out. Every single time you multiply conjugates, that's what happens. So we're going to use that pattern and put 7 plus 2 root 5 here. But if I do that to the bottom, I have to do it to the top, or else I change its value. So the top just becomes 35 plus 10 root 5. And the bottom, I get 49 plus 14 root 5 minus 14 root 5, and then minus 4 times the square root of 25. And the nice thing about conjugates, of course, is those cancel. And negative 4 root 5 is really just negative 4 times 5, which is negative 20. 49 minus 20 is 29. Like that. Can I simplify? No. What if this was a 20? Now can I simplify? All of these have a factor of 5, and notice I did not touch the square root. You cannot cancel something inside a square root with something outside a square root. So I pull a 5 out of all of those. 7 plus 2 root 5 over 4. And I can't go any further than that. Do you want to see another one? Oh, that's not what I wanted. Okay. Multiply by 6 minus 3 root 2. 6 minus 3 root 2. On top, we get negative 42 minus plus 21 root 2. On the bottom, we get 36. And then the next two are going to cancel. So they're going to be 18 root 2 and positive 18 root, negative 18 root 2 and positive 18 root 2. And those cancel. So if you want to skip those, feel free, because you know they will cancel because we're dealing with conjugates. And then the last one is not negative 9 times the square root of 2 squared. The square root of 2 squared is just 2. So negative 9 times 2 is negative 18. And 36 minus 18 is 18. Is there a number that goes into all three of those? 3. So we get 14 plus 7 root 2 over 6. That's it. Okay. Get to work.